All right, so today we are doing the natural base, which is called E. And our essential question is, how do I simplify natural log, which we call that ln, expressions, and solve PERT equations? And these are all just variables that we'll be filling in.
Exactly. So the exponential functions with e, little e, as a base have the same properties as the functions you have already studied. So the graph of f of x equals e to the x is like other graphs of exponential functions, as you can see over on the right in that graph. The domain of that graph is all real numbers.
Because it goes left or right
Yep,
always.
which that's what happens with exponential equations. And the range is y greater than 0 for this one.
Never goes below.
Right. So a logarithm with a base of e is called a natural log. So we've talked about logs, which have a base of 10. Remember, if it doesn't specify the base, it's a base of 10. So natural log, you're never going to see it written as log e, because that's what it's equivalent to. Natural log is equal to log of e, so e is the base. But they don't write it like that. We write just natural log. Yep, exactly. Okay. So the natural log is the inverse of the exponential function, just like the log was the inverse of the exponential function.
Okay.
And e is actually a number.
Okay.
And as you can see below,
I can't really see it because our pictures are
yeah, but they can look at it on their notes.
It's on your notes. That's
It's a number.
Okay.
And it's actually not repeating if you look at the whole number. It may appear to be, but it is not.
Got it.
Oh, and what I wanted to point out, sorry, one other thing, inverse, as you can see, the two graphs, e of x and ln of x, one's blue, one's red, they reflect over the line y equals x, thus it proves they're inverses of each other.
Got it.
So let's see, what else do we have here? The domain of f of x equals natural log of x is x greater than 0, as you can see on the red graph. Okay, x is the graph is to the right of the y-axis, and the range in this case is all real numbers. But it makes a lot of sense because they're inverses, so remember the domain and range flip. Now the nice easy thing here is all of the properties that you learned back for logs are going to hold for natural logs. Every single property. Correct. So here we go. On example 1, why don't we start with that? As you can see, I don't see a base. And when I don't...
So we can assume it's really like log of e.
Right. And if you recall, we learned a property, I don't remember what section, because they're the same, the property says the answer is just negative 5w, and you're done. Okay. Now look at the next one. Again, let's write, I'm going to scroll down for you a little bit. Let's write the base e next to natural log. See that up there?
Wait.
Remember that has a base of e, just like you, so write
right
e.
Here, you mean. Got it.
Now, because the big E and the natural log is an exponent in this case, when that's the case and the bases are the same, the answer is just not w though.
Oh, x.
They might wonder where you got a w.
Sorry.
5 plus x. Oh boy.
Oh boy.
5 plus x. There we go. All right, so now on the next ones, it's a little more tricky.
Okay.
Because whenever you have an exponential equation like this, where you have an e raised to a number and then the natural log of x, you're going to do the backwards softball. So you're going to bring that 3 backwards and up to the x. So you're going to rewrite that then as e, let's rewrite it as e, natural log, and you can write the little e as the base, just so they remember, and it's x cubed. Now look, again, like the problem, example, look at example 2, because the e's are the same, the answer is just x cubed.
Got it.
That's it. Example 2, should we then go through those? Yeah, why not?
All right, 1 second.
Okay. So now on this one, again, if you want to write the base, even though you remember you don't have to, whenever it's natural log, it's an e, because the two e's are the same. The answer is just 0.15t. Done.
All right.
Again, on the next one, you see an e, and you have a natural log as an exponent, but there's a number in front of the natural log. So you
we're gonna
have to
baseball it
do,
forward.
yep, you do. So
This
let's,
is like our E.
yep.
We're gonna baseball it forward.
So now that equals e to the natural log of plus,
Oh wait.
yep, let's not raise that up
Yeah,
there,
that's
yeah.
what I was just thinking. We have to raise the 3, not the x plus 1.
Right.
Got it. And I'm gonna put it in parentheses to the third.
Right.
Okay.
Now, again, the natural log is a base of e, so they will cancel. So you get x plus 1 cubed, and that's all you need. You're
Okay,
done.
we don't have to. Oh, phew.
No,
Nice.
don't have to expand that out. I'm not going to make them do that.
Good.
Well, now look, we have two natural logs.
Mhm.
So we have to write them as a single log. And when you're adding, that's the same thing as
Multiply.
multiplying. So we write natural log, and in parentheses, we have e to the 2x
2x
times e.
Oh,
Nope,
got it.
see that? Yeah,
Mhm. Sorry about that.
That's okay. Times e to the x.
dx.
Well, that is going to be, you have an e to the 2x times e to the x. So when you multiply those, you're
2x
gonna-
squared.
it's actually,
Oh, we're
the-
adding.
remember?
Yeah,
Mhm.
exponents.
remember when
Oh,
you
there's
multiply,
so many
when you
rules.
multiply bases that
Yeah.
are the same,
We add our
you add our
exponents.
exponents.
Got
So
it.
natural log
And
of e to the 3x. And then now look, your
wow.
base of your natural log is e, the two e's cancel, and your answer is 3x. Lots involved there.
Okay.
Okay, let's move on to our PERT problem. The
Okay.
formula for continuously compounded interest is A is equal to P e to the RT, PERT.
Okay.
A is the total amount.
Okay.
P is the principal or the initial amount.
So how much you put in to start with.
Right.
Got it.
Or how much you buy something
Mhm.
for.
Okay.
R is the annual interest rate.
And we always want that in decimal form,
Yes, we want that as a decimal. And T is time in years.
right?
So whenever a problem says compounded continuously, so if you can highlight that in our example 3,
Okay.
I'll read the problem. What is the total amount for an investment of $2,000 invested at 7% for 5 years and compounded continuously? The minute you hear compounded continuously, you know that you're using PERT.
Perfect.
So let's write that. A is equal to P e to the RT. We're
Okay.
solving for A.
Mhm.
So
Because this time it's asking what is the total amount.
Yep, and
so this is our A.
it tells us our investment. So we
This
write
is our
P, our
This
R,
is our R.
and
this
that is our T. Exactly.
Okay.
So let's plug it in.
So A equals
2,000
2,000
E
E
to the
the
0.07
0.07
times
times
5. Well, we are going to now, all we actually have to do is we have a calculator. And
Plug it
that's
in.
all you're doing is plugging it into your calculator right now. There is an E button. You take 2,000 times E and you raise E, use a caret. And I'm thinking on some of the calculators, after you do the caret button, you may have to put 0.07 times 5 in parentheses if you
Got
type it in that way, or it won't work.
Okay.
Experiment. So the answer is 2838.14. Is you round to the nearest hundredth.
All right.
That's it. Pretty easy. I
Sweet.
think that's pretty straightforward.
Yeah.
Example 4 is another PERT problem that I think we should probably do in class.
Yep.
What do you think?
Yeah.
Example 5
Still asking the total amount.
is PERT.
Yeah.
Ooh.
We better go back to this.
Yeah. We'll leave those for class then.
Yeah.
Okay, so now we're on to this. Solve. Well, this isn't too bad because if we have 2 logs, or excuse
Oh,
me,
not
I didn't mean to
tens,
say log.
e's.
If we have 2 natural logs, you can turn them into a single log because you're adding, you're going to multiply. So natural log x, in parentheses now, x times 6 is equal to 3. Well, we know that's just 6x, right?
Mhm.
So should we rewrite that like that?
Okay.
And now we're going to, well, guess what? You have a natural log equation. We have to change it to exponential.
So we can baseball it.
What's
No.
our, no, not baseball. Yeah,
Loop it.
loop it.
So
So
many things.
e to the third equals 6x. And we're solving for x. So we divide both sides by 6. And then you have a thing called a handy dandy calculator that does that for you. And Miss Boyd will write you a note. And after you plug that in, you get 3.35. If we have to round, I just round to the nearest hundredth.
Okay.
And now we have a subtraction one.
Perfect.
So if you're subtracting,
We divide.
right, because we have to write it. You can't solve until your logs and your natural logs are written as a single log. 3 over x is equal to 2. Change to exponential. E squared is equal to 3 over x.
Solving for x.
Solving for x. So what do you think we should do? Well, you know what I probably would do here? I don't like the fraction. Let's get rid of that first. So let's multiply both sides by x. So the left you get x times e squared equals 3. I always like to get rid of fractions.
Me too.
Now we're solving for x. So divide both sides by e squared. And you have a handy dandy thing called a calculator. And we'll plug that into the calculator. And when we do that, if we round to the nearest hundredth, we get 0.41.
Nice. So you're really going to want your calculator this chapter.
Yes. I think we can do that in class.
Save it for class.
And this half-life, we are not doing. You can cross it off and cross it off.
Ah, there it is.
And cross it off. Simplify. So remember, maybe write them a little note that they're going to do the backwards, throw it out, backwards baseball, I call it. So maybe circle that 7.
Okay.
So now once you do that, you have a natural log as an exponent. The e and the e are the same. Remember, they'll cancel in. We kind of just gave you the answer.
Kind of.
And on the other side, use this. This should be so fast. Use the property. The base is e. The e's are the same. What can you do?
Don't guess. This is easy. No math involved.
Exactly.
See you tomorrow.